Welcome back. Let's continue, and we hope and believe that this will be another successful interaction in the field of science. I've got a question here drawn from the past papers, which is about electric circuits. So we are in the problem solving in electric circuits. The question says, the statement is saying the battery in the circuit shown below has an EMF of 12 volts and unknown internal resistance. The resistance of the connecting wires and the ammeter is negligible. The circuit you can see, and then the first statement, they say switch S is open. Switch S is the main switch. If it's open, means that there's no current flowing in the circuit. Now they say 8.1.8.1, they say write down the reading on V1. V1, it's across the battery. Therefore, if there's no current flowing in the circuit, V1 will record the potential of the battery, which is 12 volts. And then 8.1.2, they say also write down the reading on V2. V2 is the reading across the 6 ohm resistor. Therefore, if there's no current flowing, therefore V2 will record 0. Now we move to 8.2. 8.2, the statement before that, they say switch S is now closed, therefore there's a current flowing. Then the reading on the ammeter is 1.2 amperes, and the power dissipated in the X is 5.76 watts. Define power. We know from the formula of power that is in the formula sheet, W over delta T. Therefore, there are two definitions. You can define it as the rate at which work is done, or the rate at which energy is transferred, or energy is transferred. So transferred, fine. And then 8.3, we are now calculating. They say calculate the resistance of X, because we know the current in the circuit is 1.2. Therefore, the current flowing through the X will be also 1.2. Therefore, we are given current and power. We want the resistance. The formula in the formula sheet that we use will be the one of I squared R. Therefore, the power is 5.76 given. The current is 1,2. It's the statement before. Then we calculate R. Therefore, using your calculator, find that R equals to 4 ohm. That is 8.3. We go to 8.4. They say again, calculate the external resistance of the external resistance of the circuit. Now we are using the formula that we know. When we calculate the effective resistance, it will be 1 over R parallel equals to 1 over R1 plus 1 over R2. I think there are only two lines parallel there, or some they like manipulating formulas. We can write this 1 over R1 plus 1 over R2, which all to exponent this one -1. There's another alternative formula of which I also like. It will be now 1 over 6 plus 1 over 6 plus 2.4, which will be 8.4, all to exponent -1. Therefore, you will get this one as 3.5 ohm. Therefore, the effective resistance in the whole R total will be now 3.5 plus the 4 ohm from the device there, then which will be 7.5 ohm. That is the total of the whole circuit. So far so good. We go to 8.5. They're saying calculate the reading on the voltmeter V2. Find the reading on voltmeter V2. So we are using our knowledge of this one, already some values are detected there. Now what I'm going to do, we are in 8.5. The reading on V2, you can see where V2 is across 6 ohm resistor. That must calculate the current flowing through this 2.4 and 6 ohm. How do you do that? Let's go to the voltage of the parallel first. Voltage of the parallel will be IR, which is the same as 1,2 multiplied by 3.5. I've already calculated that, therefore it will be 4.2 volts. Therefore each side will be 4.2 volts, but on this side the 4.2 is shared by 2.4 and 6. Therefore the best option will be find the current through the 6 ohm resistor. That will be okay, or the current through the 8.4. Also that one is another option. You can do that. Let's go for that route and say, what about the current through 8.4, which 6 is part of it? Then it will be V over R, which is the same as your 4.2 divided by 8.4. Therefore the answer will be 0.5 amperes. Therefore the current flowing through the 6 ohm is 0.5 amperes. Now we can calculate the power, the reading, the reading on the V2 now. So we've got R and current, therefore V2 will be now IR. Therefore the current is 0.5, resistance is 6. Therefore the reading on V2 will be 3 volts. That's all.